Hello there. Let us look at, um, we'll make this problem a little bit complicated. Okay. What we'll do is we'll accept an integer value n and m from the user. We'll first print n natural numbers that are exactly divisible by m. Okay. So it looks to be a simple problem, but it is not. So for that, what I'll do, I don't know which loop to use. I am not going to because it is first n. It could be 0 or n, 0 to n, right? So I know either I can use a for loop or I can use a while loop. I cannot use do while because it will be 1 to n. Okay, so that we have to be very careful. So let me just accept the input first. I'll say percentage d, okay, and of n and our and of m. So we will use the for loop because it is easy. We know we have to loop from 0 to n. So I will say for my counter is equal to 0. My counter remaining less than n. I'll do the counter plus plus. Okay. I should not give a semicolon there. If I give a semicolon there, the loop terminates there. Here what I will do is if my counter, right, whichever is the value of the counter, mod m means if it is exactly divisible, then I'll get the remainder as 0. I'll only printf that. I'll just printf percentage d comma means I want to differentiate. I'll put the display the counter. Finished. So I'll display an appropriate message wherein I'll say printf n natural numbers percentage d natural numbers, or I can say first percentage d natural numbers divisible by m. Natural numbers exactly divisible by m. So nothing but percentage d, so I'll give n and m. One good practice that we should look at whenever we write programs is to see whether we have accepted the input properly. So for that we have to echo. It's called echoing after we accept the input. Just to confirm, we will say n equals percentage d, which is our n, so that we will not have any issues to with the input. Okay, because if our input is wrong, our program may get into a logical error. So this is not a bad practice. Even if it adds some lines to our code, it doesn't matter. So m and m. Okay. All right. So the first n natural numbers, we will see whether this is going to work. So I have n and m declared. So let me save this. All right. So we will CL as this. Okay. So we have errors here wherein I have given a semicolon somewhere. I'm sorry. Here it is not required. I've given a quote. So OP. So let me give, I want to find out the first 100 numbers that are divisible by say 37. Exactly divisible by 37, right? It's nothing but multiplication of 37. The first, okay, 137 are perfect, but we have issues there wherein it says the first 100 natural numbers exactly divisible by 370, 37 and 24. So there must be a display problem there, right? So what is the display problem there? Here we have to give a slash n here so that our output comes on the next line, so that there is no confusion there. Okay, so the OP, so I'll say 137 right? The first 100 natural numbers exactly divisible by. There is a problem there. We are not saying first 100 natural numbers. We are saying natural numbers up to 100, right? Which are divisible by 37. It is not first 10 natural numbers, is it? So the logic we have to get for the first 10 natural numbers now, isn't it? But the output is only giving the numbers that are between 0 to 100 the first. So now our for loop doesn't work if you really understand here. We want first n natural numbers. So for that, what we have to do is we need a while loop because we don't know what how many times we are supposed to loop. So here we in the advanced know that we want to loop from 1 to 100. There we are saying now first n natural numbers that are divisible by whatever. So for that, I have to put something called natural number count. So let me call it as NC. It is equal to 0. Okay. So my that is my NC count, and then I'll start incrementing the counter. Right now, which says that while my natural number counter remains less than or equal to n, just remember this. Okay, please observe this carefully. Less than or equal to n, I will now, which means if the value of n is 1, so my 0 is less than or equal to n. Okay, that we will see. We will whether it is less than or equal to, or if we start from 0, that will be just as of now we'll just take it as nc less than or equal to 0 n. We will do. We will now have. We will now put the if the counter, correct. If the count first 10, if it is exactly divisible. So now we have a condition. So if my counter mod m is exactly divisible by this 0, then what I will do is, then I will put a condition here. See, what does that condition actually mean? If counter m mod m is equal to 0, correct, which means it is exactly divisible, I will print that counter, that natural number, correct, because counter is my natural number, right? So percentage d comma, looks simple but it is not. I had told you in the beginning, right? Now I have in my natural number count is increment. I have printed the first natural number, whichever is divisible by say 37. So I should get 0 and 37, right? So if I say 100 natural number divisors, I should get 100 first natural numbers which are divisible by 37. Okay. So I have NC equal to NC plus 1 now. Okay. So now does this end here? Correct. So I have to now start looping the counter as well. Whether I will just do counter plus plus. We just had something in mind and let us see if this logic works for us. Correct. So we will first give the test case. Okay. And then we can come back and make modification. That is easy. So OP. So we'll give I want first one natural number that are divisible by 1. Okay. So 0 is, so now I am getting one extra, isn't it? So that may be because of my less than or equal to. I'll just make it as less than. Let us see what will happen. So now we have made this while nc less than n. So let us go back and execute the code. Okay. So what does the code say? OP. So I want one natural number, first one natural number that is divisible by 1. So it gives me 0. So that's a good execution. I want one natural number that are divisible by 100, which is 0, which is common, right? 0 is divisible by any number. So let me now go back and do few more test cases. The numbers, I want the first 10 natural numbers that are divisible by 10. So what I should get? Multiple table of 10? Yes, correct. So now why am I not getting 100? Because I have already considered 0 as the first natural. It's a natural number, right? So now if I am looking at the first natural number, say the first 1000 natural numbers that are divisible by 37, then we get this, isn't it? So this is what is the power of the language. So I think you hope you understood that less than or equal to condition, etc. And then we put an if condition, right? And then we looked at the counter, right? So we will try, and in the later advanced C lectures that I take, which is going to help you to look at placements for tier 1 companies, right? We will actually optimize all this code, and I'll actually show you how to optimize all this code, not these simple programs, of course, complex programs. Hope you understood this video lecture. Next in the subsequent lectures. Thank you very much.